Welcome back, folks. The notes for this next part I've already written up. That's because I just recorded 40 minutes of lecture with my microphone muted. So now I'm going to try to remember everything I said and say it again. At least this time I don't have to write at the same time. So let's talk about absolute value. And I'll just be gesturing along with my mouse as I go through what I've written. Okay. Give me just one more moment to get over this frustration. And absolute value is, well, fundamentally, it's an expression of distance. It's also an operation we can do to numbers. Let's talk about what the operation means and then get into why it means distance. So the symbol for absolute value is two vertical bars, and it's a grouping symbol. It groups whatever's inside of it together. So here I would read this as the absolute value of 3 is equal to 3. And what that means is absolute value is, we can think of it as distance from 0. It tells us the magnitude of the number, how big it is without caring about whether it's positive or negative. So 3 has an absolute value of 3 because it's 3 units away from 0. Negative 4 has an absolute value of 4 because it's 4 units away from 0. It doesn't matter whether you're going left or right. Absolute value just reports on the distance. And so the absolute value of 0 is 0 because it's right at 0. Now, another sense in which absolute value means distance. So absolute value, if I plug in a positive number, I get that number back. If I plug in a negative number, I just get the opposite. So the absolute value of negative 10 is 10 because it's 10 units away from 0. Or the absolute value of 2 is 2 because that's how far 2 is from 0. Even cooler, if I subtract two numbers and put them inside absolute value bars, it's going to tell me the distance between those two numbers. So 5 minus 2 is 3. The absolute value of 3 is 3. 2 minus 5 is negative 3. Its absolute value is also 3. And that's because 2 and 5 are 3 units apart. So when I take the absolute value of a distance, I get how far apart these two numbers are, the absolute value of a difference. Now I want to try solving some equations with absolute value in them. Okay, so wall of text incoming, but don't worry, I'll explain it piece by piece. So I started with the equation 2 times the absolute value of 3 minus 2t equals 6. The reason I put in these parentheses here is to remind you absolute value is a grouping symbol. So it's saying the absolute value of this whole thing, well, it has a value of 3. I can divide both sides by 2 and say this whole thing has an absolute value of 3. What I can't do is subtract 3 from both sides. I can't do that because this 3 is inside of the grouping symbol and this 3 is outside of the grouping symbol. The only way to solve an equation with a grouping symbol in it is, first, you can get the grouping symbol by itself. This whole thing together follows all the normal rules of algebra. But to break it open, the only way to break it open is to interpret it by its meaning. There's two ways to think of this thing's meaning. I can think of it in the distance from 0 sense. I can think the thing inside the absolute value bars has a magnitude of 3. So either it's negative 3 or it's positive 3, because those are the two numbers that are 3 units away from 0. So this whole thing is either sitting right here or right here, because it's 3 units away from 0. So that's the first way to think of it. And let's solve the problem, and then I'll talk about this interpretation after. So either this thing inside is 3 or it's negative 3. If it's 3, I can subtract 3 from each side and then divide both sides by negative 2, and I see that t must be equal to 0. Or this whole thing could be negative 3 because that also has a magnitude of 3. So if this whole thing is negative 3, then I can add 3 to each side, add 2t to each side, and then divide both sides by 2, and here I get that t is 3. So if I plug in t equals 0, I get the absolute value of 3 minus 0. The absolute value of 3 is 3. If I plug in t equals 3, I get the absolute value of 3 minus 2t. That's the absolute value of negative 3. That's also 3. So this one gives us the thing inside is 3. This one gives us the thing inside is negative 3. And so those are the two ways that this expression can have a magnitude of 3. Now, the other way to think of it is this 2 minus 5 or 5 minus 2 says the distance between 2 and 5 interpretation. I could think the distance between 3 and 2t must be 3 units. So I wrote that down here. 2t has to be 3 units away from 3. It could be above it 3 units or below it by 3 units. Either way, it has to be 3 units away from the starting point of 3. So 2t could either be 0 or it could be 6. And that means t must be either 0 divided by 2 is 0 or 6 divided by 2 is 3. So we get the same answers no matter which way we interpret it. And either one of those is good. Now, normally I say something like, use whichever interpretation makes most sense to you. And that's what you should do on a test. But I want to tell you more. The bare minimum to pass this class is the syntactical understanding. And I don't like this very much because it's actually more effort than the semantic understanding. If you wanted, you could get through this class not understanding a thing about absolute value, except that these are the rules we follow to manipulate it, and then we can use the normal rules of algebra. I don't like that very much. Good would be to understand one of these two interpretations and say, okay, when I see this, I know that this thing inside the bars is 3 units away from 0, so it's either 3 or -3. That'd be good. Or understand it this way. Either one of these is good. If you pick whichever one makes you more comfortable and then learn that, that's good. Better would be to understand both. And best would be to understand why these two really mean the same thing. That's the deepest understanding, is if you can understand not only that both of these work, but understand why they'll always give you the same answer, then you've learned something, you've glimpsed something very close to the heart of the matter. So normally I say solving problems is the best way to get better at solving problems, and that's true. But to get a deepest understanding of the mathematics, it might help to just sit quietly and ponder for a bit. Why does this whole thing being 3 units away from 0 mean these two things are 3 units apart? How do those two coincide? And if you can work that out, then you'll understand something very special about absolute value. Anyhow, let's go on to the next example. Let's say I was told that 4 equals 2 times the absolute value of 3t plus 6 minus 6. So again, the only way to deal with this is to get the grouping symbol by itself and then interpret its meaning. The reason I'm emphasizing this now is that function notation is also a grouping symbol. We'll get to that in a bit. We'll start chapter 3. Starting chapter 3 is where we start functions. Functions are a grouping symbol, and they're a very important one because for the rest of the semester, we'll be working with functions. So that's 2 lectures away from now. And so it's important to understand I can add 6 to both sides. I can divide both sides by 2. And that gets the grouping symbol by itself. What I cannot do is I can't say this 6 and this 6 cancel, because this one's trapped inside and this one's trapped outside. They cannot communicate. The only way to crack open what's inside the grouping symbol is to interpret it by its meaning. So here when I say 5 is the absolute value of 3t plus 6, I've got the grouping symbol by itself. That was the first necessary part. And the second thing I have to do is understand what this means. It's saying the magnitude 3t plus 6 is some number, and its magnitude is 5. So either it's equal to -5 or it's equal to +5. Those are the two numbers that are 5 away from 0. So either it's equal to 5 or it's equal to -5. I set up both of those, and then I solve them. Subtract 6 from both sides, divide both sides by 3. Subtract 6 from both sides, divide both sides by 3. So if I plug in t equals 1/3, then this would be -1 plus 6 is 5, and that has a magnitude of 5. If I plug in t as -11/3, then this is -11 plus 6, which is -5, which has a magnitude of 5. So there's one thing I can plug in to make the whole expression +5. There's another thing I can plug in to make the whole expression -5. I just know that the whole expression has a magnitude of 5, so either one of these could be correct. Next example. Let's say that I said 5 plus 6 times this equals 2. First, I need to get the grouping symbol by itself. So I subtract 5 and then divide by 6. And I get the absolute value of this thing is negative 1/2. Now that would mean that this whole thing has to be negative 1/2 units away from 0. It has to be closer than no distance at all. 0 units away would be no distance at all. This is closer than that, and that's impossible. There's no such thing as a negative distance. You can't be closer than 0 units away, because then you would already be there. There's no thing closer than already being there. So it just doesn't make any sense to say that an absolute value is negative. Absolute values are magnitudes, and those are by definition always positive, is another way to think of it. So since distance can't be negative, there is no solution to this equation. Absolute value is never going to spit out a value of negative 1/2. So we isolated the grouping symbol, but when we found out that this was impossible, we knew we could go no further. Let's set up a different problem, slightly different, and say instead, let's say that the left-hand side was equal to 11. So I can subtract 5 from each side to get 6. And then I can divide both sides by 6 to get t squared minus 1 equals 1. Now there's 3 places you could go from here. You could say, okay, that means that the thing inside has a magnitude of 1. It's 1 unit away from 0, so it's either positive 1 or negative 1. And that's actually how we're going to set up the algebra. We're going to say this thing inside, it has a magnitude of 1, so either it's equal to 1 or it's equal to negative 1. Either of those things is 1 unit away from 0. The other way to interpret this geometrically is to say the absolute value of a difference is distance. It's saying that this thing and that thing, the distance between them is 1 unit. So t squared is 1 unit away from 1, so it's either 2 or 0. Those are the 2 things that are 1 unit away from 1. And that's actually the next step in the algebra, is to add 1 from it to each side and say, okay, t squared equals 2 or t squared equals 0. The fact that these line up so neatly with this should give you some insight. When I said earlier, meditate on why these two are the same, this should give you some insight into why. Hopefully this helps. So either t squared is equal to 2 or t squared is equal to 0. Those are the 2 numbers that are 1 unit away from 1. So if t squared equals 2, then t is plus or minus the square root of 2. Remember, the square root property says negative root 2 squared or positive root 2 squared. They're both 2. If t squared is 0, then t has to be 0. So there's 3 solutions this time. There's 2 different things I could plug in to make this in the symbol. If I plug in root 2 or negative root 2, then this is 2 minus 1, which is 1, and 1 has a magnitude of 1. If I plug in t as 0, I get the absolute value of 0 minus 1. The absolute value of negative 1 is 1, because it has a magnitude of 1. So either one of those works. Last thing I want to do in this video is kick things up one more notch and say, what if we have 2 absolute values? What if I say the absolute value of this thing and the absolute value of that thing are the same? That means that these 2 expressions, 2x minus 5 and x plus 1, have the same magnitude. So let's look at the red text on the right here for a minute, and then I'll show you the algebraic solution. So ignore all of this for a moment, and we're going to talk about what's over here. Some things that have the same magnitude, the same distance from 0. I'm saying 2x minus 5 and x plus 1 are both the same distance away from 0. So for example, negative 5 and positive 5 are the same distance away from 0. They're both 5 units away from 0. On the other hand, 11 and 11 are both 11 units from 0 by virtue of being the same number. Or negative 2 and negative 2 both have a magnitude of 2. So what I'm saying is these 2 expressions, 2x minus 5 and x plus 1, they have to have either the exact same numerical value or exactly opposite numerical values. We're going to find out that they can either both be 7 or they can be negative 7/3 and positive 7/3. They can either have the same value or opposite values. So the way I'm going to get there is I'm going to say, okay, there's 2 things that could be happening. They're either the same, like these, or opposite, like these. If I assume that they're the same, I'll just set them equal to each other. 2x minus 5 is the same as x plus 1. So I subtract x, add 5, and I get x equals 6. Or I could assume that they have opposite values, and I could say this thing is negative of that thing. Now I had to put these parentheses here because I'm saying 2x minus 5 has the opposite value of x plus 1. So I'm saying if I took x plus 1 and I made this whole expression negative, so I put a negative in front of the whole thing, then it has the same value as 2x minus 5. So I'll distribute this minus sign, add x to each side, add 5 to both sides, and I get 3x equals 4. Divide by 3, x is 4/3. So if they have the same value, x is 6. If they have opposite values, x is 4/3. And let's take a look at what that does. If I plug in x equals 6, 2x minus 5 is 2 times 6 minus 5, which is 7. And x plus 1 is 6 plus 1, which is 7. So if I plug in x equals 6, then both of these expressions are worth 7. And of course, 7 and 7 have the same magnitude. On the other hand, if I assume they have opposite values, I find out that x must be 4/3. Let me plug that in and see what happens. 2x minus 5 would be 2 times 4/3 minus 5. So that's 8/3 here. 5 is 15/3. So I have 8/3 minus 15/3. I need that common denominator to subtract. 8 minus 15 is negative 7. Altogether, I have negative 7/3 inside these bars. Over on the right, x plus 1 is 4/3 plus 3/3, because 1 is 3/3, and that's positive 7/3. So if I plug in x equals 4/3, I get a negative 7/3 here and a positive 7/3 here, but those are the same distance away from 0, so that solution works too. So there's one value of x that gets me same values and one value of x that gets me opposite values. And since I don't know which I actually have here, I just know they have the same magnitude, I'm just going to report both values of x. So my solutions are the two values of x that give these things the same magnitude. Let's do one more example. And remember, if you get stuck on any of these, that's fine. Just bring it to me in office hours or send me an email. Suppose that this expression and this expression have the same magnitude. Let's do one more example. So then either they have the same value or they have exact opposite values. Either they're both the same number, and so they're the same distance from 0, or they're the same distance from 0 but on opposite sides, so one's positive and one's negative. I don't know which one's positive and which one's negative, but I know they have opposite values, so I can say this one is equal to the opposite of that one. I could put this minus sign on either side. I could also say 10 plus 2x is negative of 3 minus x, and that would give me the same solution. So it doesn't matter which way you write that. So if they're the same, then I just set them equal to each other. If they're the opposite, then I just set them opposite to each other by saying one is equal to the opposite of the other. Doesn't matter which one is which. And then I can solve either way. So over here, I'll add x to each side. Then I'll subtract 10 from each side. And then I will divide both sides by 3. So x is negative 7/3. This is just solving a linear equation. Over here, the first thing I have to do is simplify. So I will distribute this minus sign. Remember, I'm saying this whole thing grouped together is opposite in value from this whole thing grouped together. So I have to put the minus sign on this whole thing grouped together to represent that. The parentheses are built into the absolute value bars. This is really the same as the absolute value of, well, parentheses 10 plus 2x. I don't need those parentheses, they're redundant, but if it helps you to write them, then do. So this is 3 minus x is the same as negative 10 minus 2x. Then I will add x to each side. So I'm adding 2x to each side, so x plus 2x is x. And then I can add 10 to each side. Well, rather, subtract 3 from each side would be faster. So I get x is negative 10 minus 3 is negative 13. So if I plug in this x value, I get 3 minus negative 13 is 16. And 10 plus negative 26, 2 times negative 13, 10 plus negative 26 is negative 16. So if I plug in negative 13, that's the only way to give them opposite values. Any other x wouldn't do it. But if I plug in this one, I get 16 here and negative 16 there. Those are both 16 units away from 0, so we're golden. If I plug in x equals -7/3, I have to get common denominators to crunch the numbers, but it turns out that both of these expressions are worth exactly 16/3. You can check that on your own. I've put the computations here. Pause the video if you want to check, but if you trust me, then you trust me. -7/3 gets me a value of 16/3 on both sides, and those are, of course, the same. All right, I'm going to pause the video here and make a third recording. This is a real smorgasbord of a unit. We're going to look at a different grouping symbol next, and that's radicals. So I'll be doing this problem next, and then that'll make it back up to where I realized that my microphone was muted. So this will be the last bit that I have written ahead. All right, see you in a moment.